Good afternoon, this is Mr. Heichel bringing you your weekly science demo show, or whatever y'all have come to call it. This is week 2. We're going to talk about physical chemical properties and chemical and physical changes. So let's go back and let's review kind of what a physical or a chemical property is, and then we're going to look about changes, and then we're going to give you, I'm going to do 2 examples of a chemical change for you so you can see it in action. Works better to see it than just talk about it. So let's talk first about physical properties. Physical properties are very, very easy to identify. They're things like color, how much it weighs, what it looks like, what it smells like. So I've got a blue liquid here. This is going to be copper chloride, and we're going to use this to induce a chemical change here in a minute. But this is blue. Blue would be a physical property. Liquid would be another physical property. And then we have aluminum foil. This is also going to be another physical property. It is shiny, it's silver, it's malleable, so you can bend it. Malleable means you can roll it up into wires or bend it. So we can bend it, we can roll it up, and it's still aluminum. That would be an example of a physical property. Chemical properties, on the other hand, are a little bit more difficult to identify. So some of the metals we're going to be using, some of the chemicals we're going to be using today are going to be like copper chloride. Copper chloride is it's a reagent. It's highly toxic. So toxicity would be an example of a chemical property. So this is going to be copper chloride. This is what we're using. And it says right there, severely toxic or poison. And then we read over here, and it tells you everything you need to know about it. We're going to get to that when you get in class. But being toxic, it says it. Hazard alert, toxic. That would be a chemical property. And then we have more chemical properties that are listed right here. This says health. That's not a chemical property. Flammability, it's not flammable. Flammability is a chemical property. Reactivity is also a chemical property. Okay? The other 2 are not chemical properties. So this is extremely highly toxic. And so toxicity, reactivity, flammability are some examples of your chemical properties. The other thing we're going to be using today is what's called magnesium metal. So magnesium metal, if we look on this bag, the first thing we see is a big flame sign. So we know that this is flammable. So we're going to see what's called heat of combustion. That is another chemical property. So the change occurs when you change the shape, or you change the size, or you change the smell, or you change the chemicals that are involved. So I've already done a physical change on this aluminum foil by taking aluminum foil and busting it up into little bitty chunks. And I did this because I want it to be able to react, so I'm increasing the surface area of it. Now what we're going to do a chemical change to this aluminum, and we're also going to do a chemical change to this copper chloride, so the magical blue liquid. So what's going to happen is what's called a double replacement reaction. The aluminum and the copper are going to switch what they're bonded to. So the reason this liquid is the reason this liquid is blue is because it has what's called chlorine or chloride in it. So we're going to pour in the copper chloride to the aluminum foil, and I'm going to stir it. And you're not going to be able to see the smoke, I don't think. Maybe you will, but it's going to give off a lot of heat. It's going to change colors, and then it's going to bubble. So when we're talking about a chemical change, we look for things like bubbling, heat, a color change, an odor change. Those are signs that a chemical change or reaction has occurred. So I'm going to take some of this, and again, this is just copper chloride. I'm just going to pour a little bit in, and it's not going to be instant. I'm going to try to cover the whole petri dish. So automatically you can see bubbles, you can see the steam coming off. It's giving off heat, obviously, because of the steam. And what we're going to see is if all these aluminum chunks are now going to become coppered color, and the liquid's going to change from a blue to a clear color, because the copper and the aluminum are switching what they're paired up with. So I'm glad you're able to see the steam. But now we have brown chunks of aluminum, and copper is normally that color. The blue liquid changed to a silver color because the aluminum replaced the copper. and we have what's called a double replacement reaction. And we know that a chemical change has occurred because we saw bubbles, we can see heat was given off, and we saw a color change. So now the liquid's actually a silverish color instead of blue. So I'll bring it up a little bit closer. You can see the aluminum chunks are now a copper color. The water, or the liquid, the copper chloride, is now what's called aluminum chloride, and it's a silvery color. So that's just one example. I'm going to give you one more example. Hopefully we don't burn the place down. So I'm going to take some magnesium metal. Magnesium metal, as we saw, was flammable. Magnesium metal is one of the components that they use in fireworks shows. So the very, very bright lights that you see emitted whenever they shoot off fireworks is an example of a chemical change. So I got a little strip of this magnesium metal. I'm just going to light it on fire with the lighter, and then I'll let you watch what takes place. It may take it a few seconds to light. Our Bunsen burners aren't working, so hopefully this lights. Starting to crack. So it gives off a very, very bright, very intense light. So I'm going to try to do that one more time, so now that you kind of know what you're looking for. Anytime something is burned and you can't turn it back to what it originally was, a chemical change occurs. So when you bake a cake, you may start off with ingredients that you can see, but the baking part changes it to where you can't get those individual pieces of that cake back. You chemically changed what they are, and a chemical change has occurred. So normally what I would do to show this is we would make ice cream, but with the impending corona, who knows what we're going to do. We're going to find something to do. So hopefully this is sufficient and sparks your interest a little bit more. I'm just probably not going to light my lighters out, but it gives off a very intense and very bright light. So just like last week, your assignment is to write a half a page over what you saw, what you thought, what you learned. Don't put you didn't learn anything, because hopefully you learned something and enjoyed it. Hey, y'all have a great day, and we will see you, some of you, on Tuesday.